So this is chemistry lesson 2. So this lesson is going to help us understand our world and staying safe. It will also help us understand exploring industrial impacts, laboratory safety, and the nature of matter. So as we looked at chemistry in the previous lesson, where we looked at chemistry as the study of the composition of matter and the changes matters undergoes. We also looked at the different branches of chemistry, and then we also looked at the importance of chemistry. So in today's lesson, we want to build on what we already learned. So since chemistry is about, we learned that its importance, it's about also making us aware so that we can make intelligence decision. It is also to make us aware of our world and how we can stay safe. Okay, it can make us explore industrial impacts, safety rules, and also the nature of matter. And that is what we will be able to understand as we finish up this lesson. Okay, so we will start with the challenges of chemical industrial activities. What challenges come with the chemical industrial activities, or rather activities that are done as a result of chemistry? When we understand chemistry, we now go out there and begin making different kind of things. So now we are saying, what are these challenges of chemical industrial activities? So we have to understand that chemical industrial activities are vital, but come with significant negative impacts on our environment and the health. So all those importances of chemistry we looked at in the previous lesson, they are good, they are vital, but they also come with other negative impacts on our environment and health. And we have to be aware of those, because if we become aware of those negative impacts of those activities that are done, then we are going to know how to avoid them. So we are saying, let us now explore these challenges and understand their consequences. So we will now start looking at the challenges that can come with industrial chemical activities. So the first one we are talking about is air pollution. Air pollution is one of the challenges or negative effect of these chemical industrial activities. Pollution itself, as we know it, pollution is the addition of harmful substances to the air. Okay, so now when we talk of air pollution, the main problem it causes is breathing. So air pollution has to do with the breathing problems. So what are some of the sources of air pollution? For instance, combustion of fossil fuels in industries and vehicles. So vehicles and machines in industry use fuel which is produced due to chemistry. As these are produced and used now to run machines, vehicles, what happens? There is pollution produced. Okay, so there is pollution produced. Now, what are these harmful gases which are produced here? We have nitrogen oxide, sulfur dioxide, and carbon monoxide. So these are some of the gases that pollutes the air if combustion of fuels in industries and vehicles happen. So air pollution is one of the negative effects of chemical industrial activities, because from those combustion of fuels in industries and vehicles, there are some harmful gases that are produced, such as nitrogen oxide, sulfur dioxide, and carbon monoxide. Now, what are the consequences? So we are saying the consequences are respiratory problems, like nitrogen itself. When one breathes in nitrogen oxide, they'll have respiratory problems. Then we have also eye and throat irritation. Like if someone breathes in sulfur dioxide, it brings eye and throat irritation. Your eye may be itching and also your throat. Then acid rain. So like sulfur dioxide dissolve in rain. So when sulfur dioxide is released in the atmosphere and it happens to rain, then what happens? It will form acid rain. Then also oxygen starvation is another consequence of air pollution, where carbon monoxide binding to hemoglobin. So carbon monoxide binds to hemoglobin. So hemoglobin is a substance or compound found in our body which carries oxygen around our bodies. But if someone happens to breathe in carbon monoxide goes to bind with hemoglobin instead of oxygen. And because there will be now carbon monoxide in the body and no oxygen, then the person will undergo oxygen starvation, meaning they will lack oxygen, and then they will end up suffocating and dying. Okay, so we have looked at one negative effect of chemical industrial activities as air pollution. Then the next one is water pollution. Water pollution is another chemical industrial effect, or is another negative effect of chemical industrial activities. So here we are saying pollution, what are the sources of pollution itself, or how do these chemical industrial activities cause water pollution? Water pollution. So we look at the source. We are saying chemical fertilizers and nutrient runoff from farms and gardens. So these can become pollutants. Okay. So because water pollution is the addition of harmful substances to the water bodies like rivers, lakes, and seas. So how does chemistry comes in? How do these chemical industrial activities come in? We already looked at the importance of chemistry in the production of fertilizer, which is used in agriculture to produce food. But as much as this fertilizer is used to produce food, some of it is washed into rivers. So these fertilizer from the farms, from the gardens, are washed into rivers. And what happens? The water gets polluted. So water pollution. So we are saying source chemical fertilizer and nutrient run off from farms and gardens. These are the ones causing water pollution. So water pollution is coming from chemical fertilizers and nutrient runoff from farms and gardens. Now, what are the effects? We are saying this leads to the buildup of toxic algae in rivers. So rivers will have that green substance because there will be excess nutrients in the river, in the water in the river. And those excess nutrients that are coming from fertilizer will cause a growth of some tiny green particles that look greenish plant that are known as algae. So this alga is not good when it grows in the river because one, it traps light from reaching the inside the river so that some organisms can receive that light. Then the secondly, this alga also uses some of the oxygen which living things in the water are supposed to use. So the effect of these chemical fertilizers into the water is that it leads to the buildup of toxic algae in rivers. Now, what are the consequences when toxic algae is builds up in rivers? What happens? This one makes rivers uninhabitable for aquatic organisms. So it makes rivers not to be good for living organisms. So aquatic organisms are organisms that are living underwater. Aqua is water. So when we say aquatic organisms are organisms like crocodiles, frogs, the fish, some snakes that live underwater. So when algae grows in the rivers, it makes rivers uninhabitable for aquatic organisms, meaning that if there are fish there, the fish may end up dying or migrating from that particular place to another. Why? Because that place has become unpleasant or uninhabitable. Okay, so it has become bad for living organisms to stay there. Also, another consequence is that it makes rivers unpleasant and potentially harmful to humans. Also, humans cannot go to that river, to such a river with algae, even to draw water from it or drink water from it. Why? Because the water itself, when you look at it, it looks unpleasant, and also it is already harmful to humans. So these are the consequences. Okay, then another effect of chemical industrial activities is actually what is known as global warming and climate change. So global warming and climate change is another effect of chemical industrial activities. Okay, so how? What is global warming itself? It is very important that we understand these terminologies like global warming in chemistry. This is when they're joining. Where have they been? Okay, so we are saying global warming. Global warming is, we need to understand what global warming is. Global warming is the rising average global temperature, is rising in average global temperature. So, in short, it is the heating up of the earth. So, one of the chemical effect of chemical industrial activities is global warming. So the earth starts warming. Global means earth. So in chemistry or in science, when we say global, we are referring to the earth itself because it is considered to be spherical or round. So we refer to it as a global. And when we say these chemical industrial activities cause global warming and climate change, global warming is rising in average global temperatures. Like temperatures begin increasing year in, year out. You find that maybe this year the highest temperature in October maybe was, let's say, 20 degrees Celsius. Next year maybe 20 20.1, the other year 20.2, the other year 20.3, then we can say there is global warming. Okay, now what is the cause of the global warming itself here? The cause is greenhouse gases from combustion of carbon compounds. Combustion, we are saying cause greenhouse gases from combustion of carbon compounds, okay, which accumulates in the atmosphere, trapping heat. So the carbon compounds, which are the source of fuels themselves, when they undergo combustion, which is burning, when a car is moving, there is fuel which is burning inside that engine. That burning of the fuel inside the engine is what we call combustion. So the combustion of fuel in those engines produces what we call greenhouse gases, such as carbon dioxide. So gases such as carbon dioxide are referred to as greenhouse gases. Why are they referred to greenhouse gases? Because they behave like a greenhouse. If you know what a greenhouse is a house which is made up of glasses throughout the roof, the wall. The walls are made up of glasses. And the reason why such a greenhouse is made up of glasses is to ensure that inside that house the temperature are high. And the greenhouses are used in cold seasons and in cold regions for growing crops which require high temperature or which require at least a moderate heat. Like there are some crops that do not grow well in cold season or in cold regions. Now, if they want to grow those plants in cold season, they should grow them inside a greenhouse. So a greenhouse, what it does is it traps heat from the sun from going out, making the inside of the house to be warmer than the outside. And if the inside is warmer than the outside, then crops grown inside the house will grow well because they'll have that heat they need to grow. Now, there are gases which behaves like a greenhouse. There are gases which behaves like a greenhouse. These gases, they cause global warming. How? When they are released from combustion of carbon compounds, these gases, when they come from car exhaust machines, they go into the atmosphere. When they go into the atmosphere, what happens is that they, let me come here, they make something around the earth there. So when they make a layer around the earth, they cause, they block heat from the earth from escaping. Because the situation which happens is this that you need to be aware of as someone doing science and someone doing chemistry. When the light and heat come from the sun, it enters the earth, but it passes through what is known as a layer known as ozone layer. So ozone layer blocks some of the rays, strong rays, which are known as ultra rays, from the sun from reaching us, but part of it reaches us, and that is the one plants use for photosynthesis. It's the one which warms the earth and ourselves. When the earth becomes heated, it also releases or reflects heat back to where it came from. So that heat has to go and pass the atmosphere or the ozone layer so that it go into outer space. So that the earth does not have a lot of heat, because if the earth is just receiving heat from the sun, it can end up getting overheated. So what happens if it overheat? Part of it is released into the outer space. It penetrates through the ozone layer and goes into outer space, maintaining the atmosphere on Earth. I mean the temperature on Earth. But if there are gases which are known as greenhouse surrounding the ozone layer, those gases blocks blocks the heat from going into the atmosphere. So they reflect it back into the earth. As they reflect it back into the earth now begins to become warmer, and that is global warming. And that's how global warming is uh, caused. So greenhouse gases from combustion of carbon monoxide accumulates, I mean carbon compounds, accumulates in the atmosphere, trapping heat. So when they accumulate, they trap heat, and that is the heat which causes the earth to warm, causing global warming. Now, let us talk about another effect of chemical industrial activities, which is climate change. Climate change, as we know it, is a long-term change. These are long-term changes in atmospheric conditions such as temperature, rainfall, etc. due to global warming. So global warming can now cause another problem known as climate change. When we hear of climate change, it is a long-term change in atmospheric conditions such as temperature, rainfall, etc. due to global warming. So over a period maybe of 10 years, there can be noticed changes in maybe rainfall pattern. Maybe already so far, maybe we can say the world is already undergoing climate change. Maybe in Zambia we are already experiencing climate change. How? If we measure the amount of rain that Zambia used to receive 10 years ago and what it is receiving now, if we discover that it is receiving less than it used to do, then we can say there's change in the amount of rains that we used to receive. Also, if we measure the temperature now and we compare it to the temperature 10 years ago, and we discover that the temperature now is more than it used to be 10 years ago, then we can conclude that temperature has increased. So changes in these atmospheric conditions such as rainfall, temperature, cloud cover over a longer period of time is what we now say climate change. So the climate has changed. So global warming, or rather chemical industrial activities, as much as they are important to us, they have also negative impact, which is climate change. Long-term changes in atmospheric conditions such as temperature, rainfall, etc. due to global warming. Now, what are the consequences of climate change? If we have increased, let's say, temperature, increased rainfall, for instance, or decreased, what are some of the consequences of climate change? The first one is flooding of coastal areas, okay, which results from melting ice caps. So coastal areas are areas closer to rivers or oceans. In Zambia, we are a landlocked country, so we cannot understand what it means by coastal areas unless if you have done some research in science, as much as I've done myself to understand. So we have areas like in Canada, for instance. Areas in Canada, there are areas that are covered with ice. You go to a river, you won't see water, you only find ice. Okay? Now, if the temperature begins increasing, that ice will begin melting. And as that ice begin melting, the volume of water in those lakes or rivers will begin increasing. So people will begin seeing floods, like floods. Where are these floods coming? The floods are coming from the ice which is melting. So those people living closer to those rivers will start seeing water rising. So those people that live nearer to rivers, those areas are what we call coastal areas. A coastal area, it is just an area closer to a river, and then you go and build there. So there will be flooding of coastal areas due to ice melting. Why? There will be maybe more temperature. Then it changes in weather patterns like wind, temperature itself, and then rainfall. So there will be changes in weather patterns. Then also we are talking of outbreak of diseases, hunger leading to poverty. So how can there be outbreak of diseases? Flooding, for instance, even here in Zambia, if we have too much rain in Lusaka, people suffer from diseases like cholera. Okay. There's also hunger as well when, let's say, Zambia experienced the uh, drought. When you have drought, what happens? People have no food. So there'll be hunger, and without food, everything will lead into poverty, because some people, farming is a source of income. If they have not farmed or they farmed, then their products have not grown, their crops. What happens? Poverty kicks in. So these are some of the consequences of climate change. So outbreaks of diseases, hunger leading to poverty. Okay. So now let us look at now industrial introduction to lab safety. So we have now had a picture of what can happen. Um, as much as we know the importance of chemical industrial activities, now we know their negative also impact. If we know the negative impact, then we can intelligently make decisions to avoid those. Okay. So having looked at that, now we move to introduction to lab safety, introduction to laboratory safety. So here we'll look at essential rules in the laboratory or in the chemistry lab. Like, it's very important to understand, because as someone learning chemistry, at some point you find yourself in a chemistry laboratory trying to experiment what you have learned theoretically, or trying to create something. So it is important that you adhere to some laboratory rules. So let us look at introduction to laboratory rules. So essential rules in the chemistry lab. We are saying the chemistry laboratory can be a dangerous place if rules are not followed. Yeah, so a chemistry laboratory can be a dangerous place if rules are not followed, meaning that adhering or following, adhering to safety rules or sticking to safety regulation is crucial. What do we mean? It's very important to ensure a safety environment or learning environment. So people must stick or follow safety regulations to ensure that there is a safe learning environment. Okay? So it is very important that we keep it safe. Keeping it safe, we do what? Lab rules to live by. We need to live by laboratory rules. Now, what are these laboratory rules are we talking about, which we should follow to ensure that the learning environment in the laboratory becomes safe? Number one, organized and clean work area. So where someone is doing experiment from, the area must be organized and clean. Then number two, always wear safety goggles. When one is in the laboratory carrying out experiments, they need to wear safety goggles. Then do not use cracked glassware. You are not supposed to use cracked glassware like beakers, test tubes, and so forth and so on. Those are not supposed to be used. Then use the waving method to smell chemicals. Like when you are in the laboratory, never directly smell chemicals. You just wave a small bit of air from the chemical to your nose so that you can smell. So use the waving method to smell chemicals, never directly. Then, never taste chemicals. No matter how enticing they look, never taste, because some chemicals are very poisonous. Then, wash hands thoroughly before leaving the laboratory. Very important, because those chemicals in the laboratory might contaminate your hands. And then when you don't clean your hands, you might transfer them in your mouth as you touch food. Then you need to clean and return tools to their proper place. So there is need to do what? To clean and return tools to their proper place. So after you use the beakers, you need to clean them and then return them to their proper uh, place where they're supposed to be. Then use tools according to their proper usage. So you are not supposed to use an apparatus for the purpose it is not meant for. Use apparatus according to the purpose they are meant for. Then long hair must be, don't wear sandals or open shoes when you are in the laboratory. Make sure you don't wear sandals or open shoes. In case of spillage of corrosive chemicals, so that you might not be harmed, you need to wear closed shoes. So long hair must be tied back. If anyone has long hair, the hair must be tied back, because the hair can act as a distractor. Then also laboratory coats must be worn and fastened. So those laboratory coats must be worn and fastened. If they have got buttons, someone must fasten the buttons so that they are protected fully. Any spillage, it will reach on laboratory, because those are acid proof. They are made of a material which is acid proof. Then never eat, drink, or smoke in the laboratory. Eating, drinking, smoking is not allowed, because by eating or drinking you may eat harmful chemicals together, or smoke, you may smoke together with the harmful chemicals. Also never touch your face, mouth, or eyes in the laboratory. The same reason you might transfer chemicals in your mouth, in your eyes, and your body. Also never suck pens or chew pencils in the laboratory. There are some people with habits of chewing pens or pencils. That is not allowed in the laboratory, because doing so might cause transfer of bacteria in their, or chemicals in their mouth. Okay. Now that we have looked at the safety in the laboratory, let us now talk about particulate nature of matter. Particulate nature of matter. When we are talking about particulate nature of matter, now we are digging into that which chemistry already told us at the beginning, that matter, that chemistry is the study of the composition of matter. Now, when do we start studying the composition of matter? Here is where now it starts. Now we are looking at the particulate nature of matter. We are looking at the nature of matter. So here now, when we look at nature of matter, we are looking at the study now of how matter is. So let's look at matter, remind ourselves, what is matter? Matter is the material of the universe that occupies space and has mass. So the material which is in the universe, which occupies space and mass, is actually matter. So what do we mean? We mean that everything around us, from the air we breathe to the stars above us, is matter. So it starts from everything that you can think of is matter, that is tangible is matter. Okay? So we have different kinds of matter. So matter is the material of the universe that occupies space and has mass. So that is that now. Now we move on to matter and the kinetic theory. Matter and the kinetic theory. So what is the kinetic theory of matter? Before we go there, when they say matter, we have already looked at it. Now they say the kinetic theory. Before we go to kinetic, we have the word theory. Theory is an explanation. It's just an explanation. Okay? Something that is not experimentary, but it's just explanation. Then kinetic is just movement. The word kinetic, it means movement. So if they say matter and the kinetic theory, they're saying we are looking at matter and the explanation about how it is. Okay, something like that. But when we say kinetic theory of matter, it's a theory. What does it state? So we say the kinetic theory of matter states that matter is made up of very tiny particles in continuous motion. This is the answer to the situation where chemistry said chemistry is the study of the composition of matter. Now you may be asked, what is matter made up of? Now the theory starts explaining to you to say matter is made up of very tiny particles in continuous motion. So they are saying, this matter which is in the universe, it is made up of very tiny particles, and these very tiny particles or small particles, they are in continuous motion. They are moving. Now, these tiny particles which make up matter are known as basic units of matter. Basic units of matter. What are these tiny particles which are known as basic units of matter? These are atoms, molecules, and liquid, I mean ions. Okay? So these are what now make up matter. So as of now we have understood the composition of matter. When chemistry say it is the study of the composition of matter. Now if we were to be asked what is the composition of matter, now we can say matter is made up of, or according to the kinetic theory, matter is made up of very tiny particles in continuous motion. And these tiny particles are basic units of matter. They are the ones that builds up matter. Okay? They are the ones that builds up matter. What happened is someone. Okay, so we are saying that now basic units of matter. These are the units that are building matter. Like now the wall, just like I said, the wall is made up of bricks. Imagine the wall is matter. So matter now is made up of basic units. What are they? Atoms, molecules, and ions. Now you should be able to answer. Oh, the matter which is around us has tiny particles which makes it. And these tiny particles are in continuous motion. What are these? Generally, they are called basic units of matter. What are they specifically? Atoms, molecules, ions. They are the ones that make up matter. So we have matter which is molecules, matter which is in ion form, I mean atoms, and matter which is in ions form. Okay? So, yeah. Now, theories, explanations. So, like when I say theories, explanation, I mean what else does the kinetic theory helps us now to explain or understand? Now, the kinetic theory helps us in understanding classification of matter into three states. Like matter, as we know it, it is classified into how many states? Three states, which are what? We have solid, liquid, gas as well. These are the three states. So, the kinetic theory is helping us to understand what matter is made up of, as much as also it is helping us to explain classification of matter into three states. So, which are solid, liquid, and gas. What else? Changes of state of matter. You know, matter undergoes changes of state. One example is change of state from liquid to solid, which is freezing. If you get a liquid like water, put it in the fridge, it will change into a solid thing. Okay? So, as it changes into that solid thing, what happens? The state also changes. So, as the state changes, then we would need to know what has happened for the state to change. And this is why we are saying that the kinetic theory is there to help us understand. Okay, now let us look at examples. This is actually 46. We were supposed to end here. Let's just finish up. Now let us look at examples of substances made up of the three basic units of matter. So we already said the basic units of matter are atoms, molecules, and ions. Now, which kind of matter or substances can we find atoms? Like noble gases are examples of substances made up of single atoms. Like if we go out there in this universe and begin looking at different kind of matter, we will find matter which is in a pure state, which is just made up of single elements. That kind of matter will have atoms like noble gases. When we go out into the universe, we'll find gases. And in these gases, we'll find gases that are existing alone as pure ones, like argon, neon. These will exist singly or single. So that kind of matter is made up of atoms. So we're saying noble gases are examples of substances made up of single atoms. Then we go to ions. Which kind of matter in the universe is made up of ions? We are saying ionic compounds such as sodium chloride. So when you go out into the universe, you come across compounds which are ionic compounds. These are like sodium chloride, potassium magnesium, potassium permanganate, potassium manganate 7. These will be examples of substances that consist of ions. So in sodium chloride, in potassium manganate 7, there are ions which are there which makes them up. Now these ions are actually charged atoms, so they are there joined together in large number. Then we look at molecules. If we also go out there in the universe, we'll find different kinds of matter that are just made up of molecules. What are these different kinds of matter made up of molecules? Covalent compounds. So what are these? Like oxygen gas, water. These are some of the substances that we can find in the universe that consist of two or more atoms joined together. Water, bromine, and the gases nitrogen and oxygen in air are made up of molecules. Okay, so this is what, ladies and gentlemen, we need to understand. So this brings us to the end of the chemistry lesson today. This is where we end here, and I hope we have learned something, because as I said, for you to understand and pass chemistry, you need to understand the theoretical background knowledge itself. If you miss this theoretical background itself, upon which questions are manipulated and changed, then you may get lost. You might study one past paper, think you understand it, in another paper, twist it, you are lost because you lack the foundation basic knowledge upon which the questions are being manipulated. They are just rotating from the same, changing things here and there, and someone get lost in the process. So we end here for today, and as usual, I may prepare the lessons. The notes, if they don't come today, then they may come tomorrow. Okay, so I will now allow you to ask where you are not clear, so that I can make few clarification for you to understand. So I'm giving you just 1 minute to make any question. So any question? Any question? Any question, ladies and gentlemen? Any question?
For me, sir, it's clear.
Okay, it's clear. Thank you so much.
As for me, sir, it's clear. Yes.
Okay, Oscar, any question?
Clear, sir.
Okay, if it is clear, guys, then thank you so much for now. I may say have a wonderful night. Bye, and see you in the next lesson.
Thank you, sir.
You are welcome.
Thank you.
You are
Mm.
welcome.